This lesson presents a modification of the program from the previous lesson. Instead of using the mouse to move an object from one location to another and having the object simply appear at the new location, the program in this lesson displays the object as it moves. This is more the drag and drop operation that we've all become accustomed to. The mouse listener interface we used in the previous program didn't quite have everything we need now. To be able to drag an object from one place to another, we need to know where the mouse is located every time it's moved, not just the moment a button is pressed. This can be done by implementing the mouse motion listener interface. It does for mouse movement what the mouse listener interface does for button clicks. The Dragger1 class is a frame that displays an object of the Dragger1 canvas class. Now, the Dragger1 canvas class implements both the mouse listener and the mouse motion listener interfaces. Remember, while a class can only extend one other class, it can implement all the interfaces it wants to. In this program, we're going to need to process mouse button presses and releases as well as mouse motion, so we need both interfaces. The declarations are about the same as they were in the previous program, but we have added a rectangle reference and an image reference. This is because we've also added an update method that uses a memory resident object to draw the images, so we won't have that flicker problem. Dragging is a form of animation, and even though the movement is not controlled by the clock, it's still movement, so we must suppress the flicker by painting the entire image on the window at once. This constructor sets the initial window size and creates a starter rectangle object. Its size being what it is will cause the update method to create a new one, but it's also appropriate for paint to use to fill the background when the window first appears. Then we call addMouseListener and addMouseMotionListener to put this object in both of its internal lists or reporting events. Remember, you must register for events or they won't be sent to you. The mouse pressed and mouse released methods are just exactly like they were in the previous example. Mouse pressed determines whether the dragging action is about to begin, and mouse released places the square at its final resting place after the dragging is complete. Here are the two new methods, the ones that are required by the mouse motion listener interface. I've never figured out exactly why there are two methods, but there are. The mouse moved method is called every time the mouse is moved inside the window if no button is being held down. The mouse dragged method is called every time the mouse is moved while a button is being held down. Now here's an important concept. If a mouse button is pressed while the mouse is inside the window, dragging the mouse outside the window still causes the method to be called as long as the button is held down. That is, positions outside the window are reported to the program until the button is released. And when the button is released, that fact is reported to the mouse released method. You'll see what effect this has in just a minute. Notice that while the square is being dragged, every motion of the mouse changes its X and Y location, and repaint is called, so the square is displayed in that new location. This has the effect of dragging the square with the mouse pointer. The update method begins by checking to make sure the current window size matches the size stored in the rectangle object. If not, a new rectangle object is created and a new image object is created to match it. Now, this program does not allow the square to be dragged outside of the window. If the X position of the square is outside the window, either right or left, its X location is adjusted to be just at the edge of the window. The same is done if the vertical position of the square is above or below the window. The paint method starts off by clearing the background of cyan and then draws the square at the current location. If the square is being dragged, it shows up in orange. If not, it shows up in black. It could have been dragged just as well in the same color, but the change should give you a better feel for how it's working. Anyway, it looks like this. Notice how it's trying to follow the mouse, but that last second adjustment in the update method won't let it leave home. In the next lesson, I'll show you another approach for keeping the dragons at home.